So this class is called Algebra 2 Trigonometry, and this is why. Chapter 9, we enter the land of trigonometric functions. And we're going to start with 9.1, which is trigonometry of the right triangle, which is really a review. I'm going to be brief and try to just focus on really more things that are appropriate for this class. Okay, so these are things that you are supposed to know from your past. And that is that the sine of A is equal to the opposite over the hypotenuse. The cosine of A is the adjacent over the hypotenuse. The tangent of A is the opposite over the adjacent. There are different ways to remember this. SOHCAHTOA is one of them. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over hypotenuse. Oops, sorry, tangent, opposite over adjacent. Some of you may know the some old hippie caught another hippie. What do we want to say here? You can fill in the words and let me know what you come up with in class. Also, back in the old days, we used to just say Oscar had a heap of apples, and then you need to know sine, cosine, tangent, which if you look on your calculator screen, you'll see nicely in that order. It goes across as sine, cosine, tangent right on the calc screen, so that's another kind of way. Sine, cosine, tangent. Anyway, that's up to you to decide how you're going to remember these things. The other thing that you need to always realize, which at this point in your mathematical career I hope you realize, and that is that the hypotenuse is always the longest side and it is crossed from the 90. I'm going to do three quick just examples over here, and recommend you do a little review elsewhere in a second if you don't remember this stuff. If you are asked to figure out what the sine of A is, you need to focus your attention on angle A. So sine, cosine, tangent really is worth nothing without some angle sitting here. So if I want to know the sine of A, I say to myself, oh, SOHCAHTOA, so that's opposite over hypotenuse. And what I like to do is I'm going to label up my triangle with respect to A. So usually the easiest thing to label is your hypotenuse, and then if you take a right across from the angle you care about, that would be your opposite, and then the only thing left is your adjacent. So in this case my opposite is 24 and my hypotenuse is 25, and I am done. Okay, next problem. Cosine of B. So now I need to change my orientation. So I'm going to go ahead and just get rid of this temporarily here with hopefully not erasing too much other stuff in the process. Okay, so if I'm going to concentrate on B now, just use a different color. So I'm going to say I might want to look at things from the perspective of B. Once again, same hypotenuse, it's still the longest side. I'm going to look at this, go across, that's my opposite, and by process of elimination, this is my adjacent. So cosine, I have SOHCAH, and that would be adjacent is 24 over hypotenuse is 25. And then last but not least, I have tangent of A. So I would go back to using my perspective from angle A, and tangent is SOHCAHTOA, opposite over adjacent. So from before then, my opposite is 24, and my adjacent, now that I'm looking at it from this perspective, is 7. So hopefully you remember this. And I just want to say that if you don't, which is possible, I would recommend that you go to regionsprep.org, and I'll show you where to go if you do go there. So when you go to regionsprep.org, rather than clicking on Algebra 2 Trig, I would click on Algebra. And then I would go ahead and I click on Trigonometric Functions. And then when you click on trigonometric ratios, you can go through all this old stuff that reminds you about sine, cosine, tangent, trig rules, and all kinds of practice. And I seriously, like, this class is dependent on you being able to deal with trigonometry without us doing a lot more review of that. So now, really what I want to do is focus on what is going to become more important to us in this particular class. So I just want to go through this one time, and at some point you're either going to understand this or you're going to start making some decision to do a little memorizing. So I want to, for a minute, look at an equilateral triangle. So all the sides would be equal. I'm just going to call the sides S, but I'm going to drop this altitude down here. And hopefully from geometry you remember that that altitude bisects this side. So I now have S over 2 and S over 2 on the bottom. So what I'm curious to know is some relationship that tells me then what this height is. How long is that altitude? So I'm going to take a spin through the land of the Pythagorean theorem here real quick. Use a different color. And I'll just call this h for height. So I have h squared plus s over 2 squared is equal to c squared, my hypotenuse, which in this case I'm calling s. So if you can come along with me here for a little wild and crazy algebra, I have h squared plus s squared over 4 equals s squared. And so now I have h squared is equal to, and I'm going to subtract this from both sides. So in preparation for that, I'm going to call this s squared 4s squared over 4, since 4 over 4 really is 1, minus s squared over 4. And so now I have h squared equals 4s squared over 4 minus 1s squared over 4, which would be 3s squared over 4. You're saying, oh my goodness, what is she doing? But I want to know what the height is. I don't really want to know what h squared is. And so when I actually solve this thing, I get h is equal to, the square root of s squared is s, the radical 3 is stuck, all over the square root of 4, which is 2. Now, this is actually going to become of some interest to us, these relationships. And I want to take you there right now by looking at a famous triangle called a 30, 60, 90 right triangle. And we'll be playing with this a little more, but once again, I just need to start getting you to be a little more sophisticated in your thinking. So from what I just did, I've really just taken a look at half of that equilateral triangle. If you recall, every angle would be 60, but since this is where I dropped down that altitude, then I've also bisected the angle, so this guy up here is 30. And just like I did in the when I first started looking at this, I mean, really what I'm doing here is I'm just looking at half of it. Okay, so we had agreed, hopefully, that this was s over 2, that all the sides are s, and I just proved to you that this is s radical 3 over 2. So now, let's just do a little more review and see what happens here. So if someone says, hey, what's the sine of 60? Well, the sine of 60 is opposite over hypotenuse, so I'm going to focus on 60 right now, and the side that's opposite 60 is this. Yeah, it's a little yucky, but it is what it is, s radical 3 over 2. All over the hypotenuse, which is s. I'm going to call it s over 1 for a minute. So now I'm going to just do a little maneuvering here. I'm going to divide this fraction, which is going to be multiplying the reciprocal. And in the end, these s's actually go away. I get radical 3 over 2. Okay, so I'm going to leave that for a second. So now I'm going to come over here and I'm going to do cosine. So the cosine of 60 then is, I want to look at my adjacent, and so my adjacent, I'll just come over here and label these sides up. So this guy right here is a hypotenuse. If I'm looking at 60, the side opposite is O, opposite, and then this would be my adjacent. So adjacent is S over 2, and my hypotenuse is S. It's called S over 1. So once again, S over 2 times 1 over S, and hello, goodbye, the s's are gone. I get a half. Cosine of 60 is a half. Last but not least, I want to look at one more, and that is I'm going to do the tangent of 60, which is the opposite, still s radical 3 over 2, all over the adjacent, which is still s over 2. And so I'm going to take s radical 3 over 2 and multiply that by the flip of this, which is 2 over s. And so now I get my s's dropping out and I get my 2's dropping out, and it turns out the tan of 60 is radical 3. And all these things are going to, in the future, believe it or not, going to hopefully mean a little more to you. I want you to notice something. Sine, cosine, and the tangent values don't care about the length of the side. Do not, I'll just write it like that, what the heck, care about the length of the side. So it doesn't matter how big this triangle is, this is going to hold. Which leads me to your calculator. So, now that we're starting to work with trigonometry, I want you to hit your mode button, and if your mode is, this is interesting. Let me just clear this. If the mode of your calculator is set in radians, you need to turn that into degrees. So that's what I want you to do now. Now you are soon going to learn about radians, and you're going to be actually wanting to be in radians, but for right now, you actually want to be in degrees. So just to see what we just did there by not even picking up a calculator to do this, if I hit my sign button and put in 60, what is going to happen is a yucky decimal is going to come out. And sure enough, believe it or not, that yucky decimal is the square root of 3 divided by 2, just like we just figured it out. Starting to hopefully get you to realize that your calculator can come in quite handy in like remembering some of this. A cosine of 60 is a half, just like we just figured out. And if I go ahead and hit tan of 60, it comes out to be a yucky decimal, and I'll let you check to make sure that is the square root of 3. Now, don't get freaked out here. This is the first kind of, foray into trigonometry, but I'm trying to start kind of getting you to see where we're headed. So, just for kicks, one other problem that you would be expected to be able to do. From a point on the ground, 100 feet from the base of a building, the tangent of the angle of elevation. So, I'm going to go ahead and draw the building. There's my building. Angle of elevation, if you remember, means the angle looking up to something. So the angle of elevation to the top is 5/4. So this is the angle that I care about. To the nearest foot, how tall is the building? So basically this angle of elevation then is related to, let's go ahead and I just label this A, B, C. And I know that this is 100 here. And I need to figure out how tall my building is. So let me go ahead and label my side. So this is my hypotenuse, the side opposite A, the angle that I know something about. Put an O, and then this is my adjacent. So, if you remember then, the tangent of A is the opposite over the adjacent, which in this case, since we are given this ratio, so the tangent of the angle of elevation, as in this angle, is equal to 5/4. And then I can just go ahead and finish this problem by realizing that the thing that I'm looking for is my opposite. I'll call that x. And I know what my adjacent is because they told me, and that's 100. So 4x is equal to 500. And when we divide both sides by 4, we get 125 feet. So, hopefully you're not too afraid. Don't worry, you're going to get really good at this stuff. We're going to practice it a lot more. So I would like you now to go to Math Excel for Schools and do the 9-1 homework. It's listed as a homework.